Hello everybody and welcome to the DeForo channel. Today's video is going to be a little bit different. We are going to be going over the movement input correction and customization asset pack for Unreal Engine. I have here started up a fresh save. It's using the third-person template. I've modified it slightly to allow for multiplayer so I could demonstrate replication with this as well. So forgive any differences between your fresh third-person save and this one. Is just for demonstrations in this video. The folder that you should have gotten with the asset pack is this one, and it should contain a single blueprint macro library. Here's the hover statistics for that in case you wanted to see it beforehand. It's extremely lightweight. I have it opened over here so we could take a look at it. The macro library contains 3 different macros, and I'll go over them a bit more in a second whenever we can kind of visualize them. It's easier to explain. The first one is Circularization, Directional Speed Modifier Circularization. This is the one that I expect most people will get it for. It's an instant fix for the diagonals providing incorrect speed modifiers, and should be completely safe to implement because of how it's attached. You'll see how we use it here and you could decide for yourself, but it should be very safe to use. That's how it was built. These two are a bit different. So the directional speed modifier for cosine changes the character's speed based upon the direction that they are traveling in. And the rate at which it changes goes along a cosine wave. I could actually, yeah, I'll add to this video as like a little pop-up or something what that wave looks like. It's really neat. It's really neat. It'll be easy to visualize here in a second. And what the true speed calculation does is reverse the effects of the cosine function. So say that you need to know what the character's speed be if they weren't affected by the slow from their direction. This would give you that. So it's useful for certain like movement additions. Like we've had to use this for the speed to or scroll to speed up or speed down, that type of thing. We've needed to reference the character's actual speed without these alterations. So should you need something like that, that is also there. These will be the ones that you would customize if you want to use your own equations. This is the one that governs movement. This is the one that kind of keeps track of what their move speed would be if this weren't applied to them. So that's how you use that. If you use your own equations, make sure that they match in between these two. And there's a ton of explanations within the macros themselves. So feel free to read through those, especially if you're going to do some customizations. The other thing that I slightly modified ahead of time, which we're going to be looking at right now, is the BP third-person character. This is where you're going to use your macros. It'll work. The macros will work with both pawns and characters. So yeah, feel free to use them with both. And I have this open here as well. So again, the modifications that I did were mostly along the lines of allowing this to be multiplayer. I've added a bit to the event begin play sequence. We could follow this down here. This is a custom tick sequence. It'll go, what, 10 times a second, and it'll tell us what our ground velocity is. And whenever we connect the cosine function, I'll also have it tell us what our true speed is, so that way you could see the two in action. And again, this is just a tracking macro. The place where we're going to be applying all of this is to the movement input, and this is the default movement input for the third-person character. I just changed the color of the comment box. So we'll demonstrate what this would be normally, completely unaffected by everything. So the first thing we're going to want to look at is max walk speed, just to kind of use this as a baseline. Right now, the default character's max walk speed is set to 500. So our velocity over here should be giving us 500 in every direction, and it will, because this is going to be capping it. So let's go over here. Let me make sure that I have one in standalone. All right. There we go. All right, so forward we get 500. 500, It's good in every direction, as it should be, because it's being capped by our max move speed number at this. So that works. And that's what makes it so tricky to realize how the math behind this works. So what we have here... Oh, before I go on any further, these are the macros that you will get. In order to get those macros, you can right-click and just search for them by name. Directional speed, boom, right there already. There's the two speed modifier macros, so this one and this one. And if you want to find this one, just type true, and it's basically the only thing with the word true in it, so you get it right away. True speed calculation. And then that's that one. So the blueprint macro library just makes them available within your character and pawn blueprints. So that's how you get those. Okay, so to make the make this problem show itself, we can put dampeners on the speed. So what I have here is a multiply node, and we're multiplying the X input, action value X. This is the left and right input motion from the player, and we're gonna multiply it by 0.5, 50%. And then we're gonna connect that, replace this original node, so now X gets cut in half and plugged into add movement input. And we're going to do the same thing with Y. We're going to reduce Y by 50%. So let's compile this, save this. All we've done is put a 50% dampener on X and Y. So our character, oh, just to show this again, our max walk speed is 500. This dampener cuts it in half, so we should be seeing 250 in every direction. So let's go in and play. Forward, we get 250. Backwards, 250. Left is 250, and right's 250. However, whenever we go diagonal, you get 353, which is over 100 greater than 250. And this is what we hope to fix. And that happens in any diagonal direction. I'm using a keyboard and mouse right now, so I only get a few. But if you were to rotate a controller stick, it would be offset in every single diagonal direction. And it shouldn't be, because we've put a 50% dampener on it, and we have a max speed of 500. You would think it would be 250 move speed. So we're going to move our circularization macro in to fix this. And this is going to demonstrate how the circularization works. You attach the inputs, the X and Y action value from your enhanced input action move function into the inputs of the macro. And then normally you'd attach the outputs of the macro, X to here and Y to here. But we're going to keep these attached just so we could see what the difference is. So whenever we start this up again, it's 250 forward, backwards, left, and right. And now the moment of truth, 250 diagonal, 250 diagonal, 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 and this will work in every single direction. It just circularizes the input, so the multiplier will never be above 1. That's basically what circularization does, and I can think of several games where speedrunners specifically, I am so sorry for the speedrunners, but I absolutely love math, and this was a fun challenge, but I'm so sorry. Speedrunners use the diagonal speed a lot to, like, bunny hop faster than they should normally be able to move. I've seen people climb walls with it. It's definitely a common thing. This will fix that. This will fix that. And again, I'm very sorry, speedrunners. So let's take out these dampener nodes. I'll connect the X to the X and the Y to the Y. And we'll move these back down. And I'll just show you what this is like as it would normally be connected. So if you need to use the circularization macro for a quick fix, this is what it should look like fully set up for you. It's literally just as easy as plug the macro in and you're good to go. So whenever you plug the macro in, this is what it should look like. Just a smooth 500 in every direction. It'll seem the same, but it is capped at 500, whereas before, the diagonals wanted to go above 500, but the game was capping them at 500. Now, like, they just can never go above 500. So that is fixed, and it should fix any of the slowed motion or diagonal bunny hoppings in your game. Now the cosine functions. These are really cool. These are really, really cool. So we'll start off with just the directional speed modifier with it outputting our velocity, and then we'll restart it again, and I'll connect the true speed calculations. You could see it with both of them. And we have 500 move speed. We never changed that. The way that this works, you're going to want to change... Whenever we were running around a second ago, if I went left, the character would turn and face left and run forward, but in a left direction. The directional speed modifier doesn't really apply to character movement like that. This assumes that whenever you go left, you're strafing, or like you're not turning to the left and walking forward. It assumes that you're doing some sort of abnormal left motion other than turning. And so whenever we use this, we're going to have to turn off rotation. Orient rotation to movement must be on false for this. And you'll see why. You'll see why. It'll make a ton of sense. So, that's the one thing we're going to have to change about the character. However, the movement speed stays the same. We're still at a 500. And this should demonstrate how the cosine movement function works. So forward is 500. Backwards is 353. Left is 461. Right is 461. And the diagonals are offsets of those. They actually go along a smooth gradient curve. So let me do like a forward right back arc for you real quick. So forward 500, diagonal 90, 60, 15, 353 backwards. And the left side mirrors that 415, 461, 490, 500. That's what it looks like in a circle. And if someone had a joystick, it would be a smooth gradient all the way through. So this is what the cosine modifier does. So if someone's backing up like this, if like say you are actually walking backwards, it's probably going to be slower than you can go forwards. And that was the idea that kind of led to making this. However, if your character is controlling like a dog or a pig or a monster or something where this curve might be different, you can use the cosine macro to implement your own movement curve equation to kind of mirror that. So say you want the backwards move speed to be like 10%, because I would think that dogs move backwards pretty slowly. So like 10% for a dog, but like 100% forward. You could come up with an equation that would turn this from, into that. So that's how that would work. And well, we already have this plugged in. Let me go over here and cut this on. So now we're also going to be outputting true speed. So we have normal velocity, like the character's actual velocity will be blue. And then we're going to be taking out the effects of the cosine equation, and the green print will be the true speed velocity, which doesn't change anything, but just lets us know what the character's speed would be roughly if they were unaffected. And I have to say roughly because this is calculated separately than this, just to make this as efficient as possible. You could technically, if you want to, combine the two in some way and have it be extremely accurate, but it's accurate enough. So with the true speed calculation output hooked up, this is what we start to see. So forward is 500. Backwards, here's where you see the difference. Backwards in green, the true speed was still 500-ish. It's a little bit off because of how it's calculated. But the character is actually moving at 353. And that's how this should be used. The green just tracks what they would be at if the cosine weren't applied. And again, with left and right, it works the same way. The diagonals, it also works. And again, if you need this to be extremely accurate, you can combine it in the same sequence as the original cosine curve and kind of pull the variable out of that as you need to. So let me, again, really quick before the video ends, show the replication, just so that way that's really, really clear. And I'm going to unplug this so that way the screen is not cluttered at all. And we'll cut this back on. Again, this is replication with movement along a cosine curve. And we're going to be using the client box, and we could look at the speeds in the other box. So despite this being a pretty complex movement curve, it still perfectly replicates, at least within Engine. I haven't been able to personally try this in a fully fledged multiplayer game yet, but due to how it's connected, I think it would work. So that's how this all works. If you have any questions, feel free to leave them in the comments or use any of the contact methods that I had provided on the store page. And again, this is the movement input correction and customization asset pack for Unreal Engine.